Okay, let's go ahead and get started in this lecture on further explorations in Austrian value and utility theory. And as we said on Monday, in this lecture, what we want to do is provide an overview of the alternative mainstream treatments of value and utility, at least some of these. And then we also want to take up questions of cost theory in this lecture. So we'll also provide some, again, overview, critical overview of the mainstream theory of cost. And then if we have sufficient time, we will cover in a little bit more detail the Austrian theory of cost, of the cost of production. I think Dr. Klein talked a bit about this theory in his lecture yesterday, and so I'll put that at the end in case we don't have time to cover that. First, though, let's start just with a quick overview of what we talked about on Monday. Remember, there we said that the fundamental principle from which value theory comes is choice, that in the face of the scarcity of means, we have to choose in order to act, and if our choice is to be purposeful, consistent with the purpose that we have in mind in acting to the attainment of some end that we find valuable, then we must make a judgment in our minds of the benefit that will accrue to us by attaining one end relative to another. And this gives us then the basic concept of preference, this idea of an ordinal rank of valuation that we form in our minds between options that present themselves to us or that we perceive to be available to us when we act. And then remember, we said that there are two critical characteristics from an Austrian view of value at least at this fundamental level. This is first that value is subjective. And by this, remember, we simply mean that value is a state of mind. Value exists in our mind. We're not talking, when we use this term subjective, about whether or not our valuations are opinions, whether they're based on, absolute principles of ethics or something of the sort. We're simply saying that they exist in our minds. They have no external property. And if they have no external characteristic, then it isn't possible to engage in arithmetic operations with respect to value. We can't measure value. We can't define a unit of value, at least not a useful public unit of value. And so we're left just with ordinal ranks. So we're just left with the notion of preference, preferring one thing to another. And then remember, the second characteristic we talked about is that value is not constant. We cannot presume that there's any constant, quantitatively definite relationship between external circumstances that are important to us in our action and the value that we place upon them. We can have a different valuation. It's easy to imagine valuing the same circumstances differently than we actually did in action, or having alternative states of mind, judgments in our mind with respect to these conditions. And so there's nothing quantitatively definite about external circumstances in our actions, because how these external circumstances affect our actions is always a matter of judgment in our minds, which can vary from one moment to the next or over time. And then we said, of course, that because of this, we can't formulate mathematical functions of value for the lack of having a constant, right? We can't write out equations. There's no such thing as a utility function because we can't suppose that there's something like a constant in the relationship between, again, whatever these external circumstances are and our valuations of these circumstances. So for the lack of constants, we can't write out functional relationships with respect to utility. Okay, now let's go into some different material on again the bridge between what we wish to talk about before and what we talked about before, excuse me, on Monday, and then what we want to go into today is really methodology. And so again, let me just briefly recount what you've heard about the Austrian position on method. This is really, to put the point differently, this is really the critical difference between the Austrian approach and the mainstream approach. The critical difference is really one of method, and everything sort of flows out of the method that's chosen by the two different schools of thought. So remember, as you've heard already, that in Austrian economics, the method is praxeology. We begin with axioms. We begin, as I put it on Monday, we begin with reflective knowledge about human action that we know to be true through our own experience. And then from this beginning point, from this conceptual framework, if you will, we just use deduction to spin out what's implied by acting. So we spin out the law of utility, or we spin out other more advanced laws and so on, all connecting to each other back and traceable back to these fundamental premises. Now, these laws, of course, are not subject to empirical testing. We can't demonstrate the veracity of these laws through empiricism. And there's several reasons why this is so. And again, let me just run through these so that we have this as background. First of all, these praxeological laws are about the meaning of human action. They're requisite conceptual notions about the fundamental interpretation or understanding, the meaning that we give to human action. And obviously then they're not about the empirical results of action. They're fundamentally about what does it mean to act? What is a purpose? What is psychic profit? What's the difference between success and failure in action, and so on? They allow us, these laws allow us to comprehend action. And so it's only, so to speak, secondarily that they're saying things about external empirical results of action. Secondly, praxeological laws are formulated typically, at least, in mental experiments, right, in thought experiments. And as we talked about on Monday, many of these thought experiments don't have empirical evidence that could bear upon them. If the law of demand says that, for a given purchase, if the price would have been lower, the person would have bought more or the same amount of the good, there's no empirical evidence that could ever exist for what a person would have done under somewhat different conditions. Right? All we know is what the person did do, given that the price was whatever it was. And so we can't empirically test this law. It lacks the necessary feature of having empirical evidence that could be brought to bear upon the proposition. Now, not all laws are like this, right? Not all praxeological laws are like this. But for those praxeological laws to which you could apply empirical evidence, these are laws about a sequence of action over time. The problem with trying to test these laws is that there are no constant relationships in human action to test with respect to the empirical evidence that we have from these actions. If we say, for example, that, let's say, if the demand for a good goes up relative to its supply, then the price of the good will rise. Well, okay, so we know that this is a praxeological law, and we know that we could see this law emerging through actions over time. Right? We could see the price of a good going up over time. But again, we don't have anything quantitatively definite to test about this relationship. The law doesn't say that, if demand goes up relative to supply by 10%, then the price of the good will go up 5%. It doesn't give us any kind of statement like this, right? It's just a qualitative claim. It's just the direction of change is all that we have from the law, and not a quantitatively definite claim. Then another point to bear upon this is that these laws that we arrive at through praxeology are actually used to comprehend the historical events. Again, it's not as if we can take the empirical facts of reality and test the laws. It's that we can only understand or comprehend the event by having this theoretical framework. Remember, this is what Mises calls specific understanding, that we take praxeological laws and we take the facts of history and we put the two together, we blend the two into a separate discipline, economic history, right, where we come up with our own historical categories, or our own historical concepts by which we comprehend, we give an explanation of history. An example of this would be the word depression. This is not a praxeological, not a purely praxeological notion. It's an historical notion. The praxeological notion, remember, is the concept of the boom-bust cycle. Right? There's a boom-bust cycle that's set in motion by monetary inflation and credit expansion. Right? And it causes this intertemporal distortion of the capital structure. And then this has to be reversed because, of course, production is always aiming at consumptive ends. And this production structure doesn't best satisfy consumption, that is our spending. It doesn't best satisfy demands that eventually emerge in the future. This theory says nothing about depression per se. Right? To get to the idea of depression, what we have to do is combine this theoretical apparatus with the particular circumstances of the event that we call a depression. Why was the Great Depression great? Why did we have a Great Depression instead of just, say, a panic, which is what these things were called in the 19th century? Okay, so this is the way we get the interface between praxeology as theory and history. Right? The interface is that the two come together in a blended discipline. It isn't that historical facts test the theory. And then the last thing Mises points out about this difficulty of thinking of the empirical testing proposition with respect to praxeology is that, as he puts it, history generates what he calls complex facts that are ill-suited to empirical testing anyway, even if it was possible to have a law, an economic law that could be suitable to be tested by empirical evidence. We don't have simple facts. We have complex facts from history. In other words, the prices and the quantities, the gross domestic product, all of this data that is generated or can be assembled by historians interested in these events. All of this data is the product of the purposeful interaction of people in the market. And so all of the complex elements, causal elements that enter into people's choices and actions and so on, are behind these facts. These facts aren't, simple facts that can be created in a laboratory where other causal factors can be held constant and you can change one and then see the empirical evidence of what a change in that one causal factor has on the dependent variable. We simply can't proceed this way with human action. Okay, now let's just quickly, again, give an overview of the mainstream position here. And with some nod here to the philosophers who will overlook my simplification, I will just use the word positivism to refer to this. My justification for doing this is that that's what Milton Friedman called it, right, in his famous 1953 article. So we'll take Friedman as the starting point and just call this method positivism. Okay, what Friedman then says is that the way we proceed with economics is that we begin with these empirical facts, what we know to begin with, and we sort of build the laws up from the facts, right? We establish hypothetical claims we suppose might be consistent with these facts. And then we test these hypothetical claims. These hypothetical claims would have to be stated in an empirically testable way. And then we see whether or not these claims are in fact consistent with the empirical facts or not. And if they are, we tentatively accept this hypothesis, always open to new evidence that might change our precise, quantitatively definite claims, or to reject the hypothesis altogether, perhaps, if the evidence gives us that result. And so we're constantly modifying, constantly updating, improving our knowledge, testing, as Friedman would claim that would be done in the natural sciences. Now, let me just give you a personal note about the strength with which this view is actually held by the mainstream, what power it has, what hold it has on their minds. I remember after graduate school, I had a mainstream training in graduate school. Went to a standard neoclassical program. Didn't hear anything about the Austrians except in a monetary theory class, the name boehm-bawerk, which may seem rather strange. Remember, boehm-bawerk said he didn't know anything about monetary theory, but his name came up in a monetary theory class, and it was about his theory of the roundaboutness of production, and that was it. That was all I ever heard of the Austrians in graduate school. But after graduate school, I started doing my own reading. I was reading through Hayek and then Mises and Rothbard and so on. And I just gotten into human action. I was reading Human Action. This was in the mid-'80s. And there was a colleague of mine who was a libertarian who knew some of he was an economist, and he knew some of this literature about Rothbard and Mises and so on. And so we got into a discussion. I was reading through Human Action and saying how great it was and how brilliant Mises was and all this stuff. And he said, "Oh, you ought to read this short review written by Terry Anderson of Human Action." This was Terry Anderson is a free market environmentalist economist in Montana State and Perk and all that. A good economist, written a lot of interesting things and so on. And so, sure, he gave it to me. He gave me this review, and I read it. And basically, what Dr. Anderson said was, "Oh, this is really a good book. It's Mises is obviously a brilliant guy, but none of what he gives us in this book is operationally meaningful. He gives us no testable propositions." And so he just dismisses the book entirely as unscientific, right? Unworthy of being included in any canon of economic theory, because nothing in it is testable. I thought it, by the way, I suppose my colleague was trying to present me with a crossroads, right, by giving me this. I had to choose, but dismiss Mises on the one hand, so I obviously chose the good side, not the dark side. Right? Well, so anyway, let me just give you a little schematic of what this difference looks like. So praxeology, we might diagram it this way. We say we start up here with axioms. And then we proceed by deduction to establish these laws of human action. These axioms, remember, are axiomatic. They're self-evident propositions, again, that we hold about action. The deduction that we use then is just verbal logic, just regular old formal logic. And we come up with these laws. And then the laws, remember, permit us to have specific understanding of historical events. So the chain of movement here in reasoning is start with the axioms, we move down to the laws. We then blend the laws with historical facts to give a specific understanding. So it looks something like that. And then positivism, we might write out this way. With positivism, we begin down here with the historical events. This is our beginning point. And then from these we get empirical facts. And remember what we said before about these empirical facts. These empirical facts are complex. We might say they're distilled from the historical episodes, right? They're not scientific facts like one would arrive at in laboratory experiments. And so this method of positivism has a difficulty here, a difficulty from the very beginning point. Then we have the test of the laws. So notice we're moving up this way, right? These laws then have to be obviously operationally meaningful. They have to be hypothetical claims that have a quantitatively definite statement in them that can be tested by this evidence. And again, economic law then becomes tentative, not as it is in the Austrian conception, something like universal truth. Right? All action aims at a preferable state of affairs or something, but just a tentative claim that can be overcome by new evidence. And then we have the last part of this, of course, and this is the part we want to examine. We also have a deduction process from what we might call assumptions. Now, I would claim that the arrow of reasoning is still going up here. In other words, the Austrian view is that we start with basic truths about human action, and then we just apply deduction and let the chips fall where they may, right? Whatever we find to be implied logically from these laws, we accept as correct. Of course, we might be wrong, and someone could show us that we'd made a mistake in logic or something. But we always proceed down in this fashion, so to speak. Now, in a way, though, the positivists don't do that. They work backwards. In other words, they say what we need to have in order to be scientific is an empirically testable law. We have a quantitatively definite statement about demand or something that we can test with empirical evidence. And then they say, what then does this imply about utility? What could we say about utility that then is consistent with this law? And so they're really reasoning backwards to say, okay, what should we say about utility? Now, by the way, there's some mainstream economists who say we shouldn't do this at all. We shouldn't try to connect economic laws, these testable propositions, to utility at all, precisely because it seems problematic, right? They want, in a way, they want to have their ordinal utility, and yet they're quantitatively definite, testable propositions. It seems trying to square the circle here, sort of a difficult putting together of these elements. So this is where the whole development of mainstream utility theory comes from. Right? To try to see how it's possible to make statements about utility that give us as a logical consequence empirically testable laws. Okay, now let's talk about these claims themselves. And Rothbard helps us here by giving us an introduction to what we might call the errors of the positivist view in utility theory. And he says there are really two different kinds of mistakes that are made from the Austrian view by the mainstream. And remember, again, these mistakes stem from the desire to have laws of utility from which you can derive operationally meaningful economic laws, testable propositions. Right? You have these laws of utility, or what you say about utility has to be consistent with, logically consistent with these testable propositions. So Rothbard says there are really two ways or two aspects to this project. Both of them are erroneous. The first he calls psychologizing. So in some instances, the mainstream does this by introducing psychological theories, if you will. In other words, they seek operationally meaningful propositions in the mental activity itself. So what they're, one way to put this, what they're striving to do is to make utility theory really a sub-branch of psychology. Not praxeology, not the logic of action, but of some psychological claim. Now, oftentimes what this reduces to is treating preferences as separate from action. Just saying, oh, we have a preference ranking. We assume certain properties of it that seem reasonable of a, let's say, a rational person, right? And so then we just proceed from there, right? We just say, here's our utility claims, our claims about utility, and they're such that we can derive these operationally meaningful laws. One example of this is Samuelson. Paul Samuelson and his concept of a revealed preference. Remember Rothbard, when in writing about utility theory, he says, he's introducing this concept we talked about on Monday of demonstrated preference. He says, it would be perfectly reasonable for us to call our position revealed preference. But unfortunately, Samuelson has already used this for an entirely different idea. And so we'll call our, Rothbard says, we'll call our idea demonstrated preference. So Samuelson's idea of revealed preference is that you assume this underlying utility preference map, if you will, that has certain properties that could be supported by psychological theories, just kind of reasonable, common sense positions. And then you presuppose that this preference scale stays constant, and that a person's actions then kind of map out for you this preference rank over time, this preference map, if you will, over time. Okay, so that's how he proceeds. This would be a psychologizing here. Another example of this would be questionnaires. We send out questionnaires. So we want to find out about people's preferences. We send out questionnaires and just have people answer our questions with respect to what they prefer this way or that way. This would be again a psychologizing approach. Vernon Smith's experimental economics would be another example of this. Right? We put people in laboratory situations, these artificial circumstances of acting, and we play games. We do this. Give them the money, and we have them choose this way and that way, and so on. And we're sort of trying to reveal their preferences, and then use this. We would then say, oh, see, people act like this, and then that would be the basis of then we could make some claim about how this leads to an operationally meaningful law of demand or some other situation. Now again, from the Austrian view, the fundamental difficulty with this is the methodological problem. The fundamental difficulty isn't that you can't do experiments and that psychology is worthless or something like this. It's just that this has nothing whatsoever to do with the task of economic theory as envisioned by praxeology. Now, of course, there are all sorts of other difficulties with this, but this seems to be the main thing, right? The other difficulty would be, and the other obvious main difficulty would be that economic theory should be about real action, about people's actual behavior in the market, what people do in the market, not about what they do in contrived circumstances, not about what they say they would do if they were given one option or another. What we're trying to explain is real action, buying and selling, how the prices are formed, how factors are allocated, how the capital structure is built up, and so on. We're really not interested in what people do in experimental conditions or what they do, how they answer questions on a questionnaire, and so on. Okay, now the second aspect of positivism and utility theory is what Rothbard calls behaviorism. And here he defines this as the approach to seek operational meaning in observed behavior itself. Not in utility, but in the actual behavior. So this approach just treats the human person as non-purposeful, sort of robotic or mechanistic. And in essence, it makes utility theory just a sub-branch of mathematics. In fact, it violates the two principles of utility that we had developed earlier. It presumes cardinal units of utility, so that arithmetic operations could be performed. And it presumes constancy of preferences. So again, that operationally meaningful claims can be derived from this. Now, of course, the mainstream would not readily assent to this criticism, right? They would, as I suggested before, what they are trying to do in this top part of their method is to square the circle. They're trying to show that it is possible to have operationally meaningful laws that can be tested and yet retain this sort of Austrian notion of utility, the notion of ordinal ranking. Okay, so how have they done this? And there are basically two approaches that the mainstream has taken to trying to square the circle here. In other words, again, what they're trying to show is that you can start with ordinal ranks, you can have your ordinal rank and operationally meaningful laws at the same time. Okay, the two ways that they've done this are first, to say that ordinal ranks have quantitatable representations in cardinal numbers. That it's perfectly permissible to represent an ordinal rank with cardinal numbers. We'd say something like this, that let's say a person ranks options A, B, and C in this preference order. Right? So A is preferred and B is less preferred and C less than B. And this approach says, well, we can just arbitrarily take any particular cardinal numbers, and as long as we attach a higher number to the highest ranked option, and then a middle level number to the middle ranked option, and then a smaller number to the lowest ranked option, we can say that this set of cardinal numbers represents the ordinal rank. Now, when this method was first tried, by the way, both of these methods actually are fairly old. They both come from the late 19th century. Boehm-bawerk, for example, talked about this kind of thing, and Mises wrote about it in the Theory of Money and Credit, criticizing these approaches. The first criticism that was made of this, I think, is the definitive one. This isn't. It isn't when you do this kind of thing that you can claim that these two are equivalent. Right? So you're representing the ordinal rank by a series of cardinal numbers is not the same thing as saying that they're equivalent to each other. They're not equivalent, right? Once you introduce cardinal numbers, you've added something to what you had before when you just had an ordinal rank. And the way that this worked itself out in the economics literature was, in other words, the first criticism that was given in the economics literature of this approach is, well, what you've added by this numeric structure is a particular proportional relationship between these numbers in the rank order, right? The rank order doesn't have a fixed proportion, like a numeric 10-unit decline as you go from A to B to C. If somebody simply ranks one thing above the next, we don't know what the distance, the cardinal unit distance is between the two rank orders, right? We don't know this. We don't know that there would be something like a fixed proportion or a fixed amount of distance between A and B and measurable in cardinal numbers. Now, those who wish to proceed with this representation theory answered to this with the theory of linear transformations. They said, well, okay, if the problem is that you're saying there's a 10-unit difference between A and B, and you can't legitimately claim that there's any particular amount of difference between A and B, then we can just do a linear transformation of these numbers, and change the distance. And yet with a linear transformation, the basic function is always the same, right? The function is, y is equal to x, or y is equal to 2x, or 3x, or 4x. We have basically the same relationship. It's just differing by a constant, right? So we can still work with one function as a representation of the ordinal rank, and we can ignore the fact that we can overcome the fact that there is a fixed distance between the ordinal ranks, right? So we can say, for example, we could double these numbers and say, well, we can just say now with this set of numbers we have the same proportion between the numbers, so we preserve the basic functional structure, but we've increased the distance between the ranks by twofold, right? We've doubled it. Or we could cut it in half, right, from its original level. And so we can get any difference. We can get any difference between the ordinal ranks. And so therefore we can proceed. This is okay to proceed this way. Now perhaps you already see the difficulty in this. The linear transformation, though, imposes on the ordinal rank a fixed, quantitatively definite proportional relationship between the numbers that represent the rank, right? To change the amount of cardinal units between the rank doesn't change the proportion of these numbers to each other. That's still fixed. And in fact, that has to be fixed in order for a linear transformation to do what these economists wanted it to do. In other words, for one function to represent all of these different possible unit differences between the rank order entries, between A and B and C. So clearly, the same criticism, the original criticism just rears up again. Like the original criticism was that by putting numbers here, you've added something to the ordinal rank. You're not representing it, you're adding to it. And you're still adding to it, even with linear transformations, you're adding to it this fixed numeric proportional relationship between the entries, the cardinal entries, that you're using to represent the rank. To put this case slightly differently, if you wanted to have a set of numbers that truly represented every possible numeric set that could be contained in an ordinal rank, then it would include all functions. It would include every possible, at least linear function. You would have to, for example, you'd have to include possibilities like this that didn't exist in these proportions. Let's say 100, 85, 70. That too would be a possible cardinal number sequence that would represent this ordinal rank. So would 90, 89, say 75. Right? And I can pick an indefinite number of combinations because I can always just divide these numbers. I can always go to fractions, right, and provide innumerable particular functional forms that represent this ordinal rank, all at the same time. Now, of course, in conceding this, we don't concede very much, right? Because as we'll show in a minute, the whole proposition, the whole reason for coming up with this scheme, the proposition in mind is that once we have the cardinal numbers attached to the ordinal ranks, we can just directly use them to derive demand. We can go to just a direct derivation of demand. Right? And we'll show how this is done with indifference curves in a minute. But notice, with this kind, if it's true that a single ordinal rank can only be represented by all linear functions, well, then you can't go to a direct derivation of demand. Right? You don't know, in other words, as you move from one price to the next, which functional form the person would choose, consistent with his ordinal rank, to give the result. And so you simply wouldn't be able to proceed. We might also point this out. It's kind of curious to turn the tables on this argument. Let's say that we had a situation where we started with cardinal numbers. Let's say, for example, we had two bunches of grapes. And the first bunch had 25 grapes. And the second bunch had 15. And we knew this to begin with. Right? We just counted them. We saw them there on the table or whatever and counted them. Now, would we say that what we should really do is just ignore these cardinal numbers and represent them with ordinal ranks? Why, in other words, don't we do this? Why don't we say that, okay, we have a larger cardinal number sum here than there. Let's just represent that relationship with an ordinal rank and say it's A and B. In other words, and conclude that no, we can't say that the second bunch of grapes has 10 less than the first. Right? We can't, or is 3/5 of the first or something. We can't do this because all we really have is an ordinal rank. All we really have is bunch A has more grapes than bunch B. Why isn't this correct if the reverse is correct? If a cardinal set of numbers represents an ordinal rank, why doesn't an ordinal rank represent a set of cardinal numbers? And if so, why can't we just why doesn't anybody offer this, right? And what's obvious why no one offers this. Because the cardinal numbers add something. It's more than the ordinal rank. It adds something that they want to have added. That's why they say it's a representation. Okay, now let's take the second case, the one with which you're probably more familiar if you studied economics, and this is indifference curves. Now, indifference curves come from a set of assumptions. Remember, again, this theory development is that we start with assumptions and then we deduce from those assumptions the quantitatively testable laws. Okay, so these assumptions are the following. A person can compare all combinations of two goods. Let's call the goods X and Y. And let's call the combinations A, B, and C, and D, and so on. So a person can compare all different combinations of X and Y and can say in any instance of comparing one combination to another that he either prefers one combination to the other or his preference is the other way around, right? He prefers the second combination to the first, or he's indifferent between the two combinations. Right? In other words, he can't choose between them. He doesn't have a preference with respect to them. So that's the first assumption, that people can, or a person can do this. The second assumption is that these preferences are transitive. If combination A is preferred to B and B is preferred to C, then A has to be preferred to C. So these preferences are consistent or transitive. The third assumption is that the person prefers more of a good to less. And the fourth assumption is that a person will trade a successively smaller amounts of Y for each added unit of X, remaining indifferent between the combinations in that trade-off. Right? So again, let me see, I'll try to repeat this again. A person will trade successively smaller amounts of Y for each added unit of X. In other words, let's say he trades 2 units of Y for 1 X, leaving himself indifferent. He's indifferent between these. His utility is the same. But then when he adds another X, he's only willing to trade off 1 Y. If he adds a third unit of X, he's only willing to trade off half a unit of Y. To trade successively smaller amounts of Y for each added unit of X as he adds more and more. Again, remaining indifferent. He's on these combinations, his utility is staying the same. So that's the fourth assumption. Now from this, then, this indifference curve framework is deduced. So the framework would then have the following characteristics. Indifference curves would obviously exist. It would be possible to, if you can say that you're indifferent between different combinations, then you can construct a set of combinations that give you the same utility. You're indifferent between having one of them or another. Indifference curves would not intersect. I won't go through the details of these points. It would take up too much time. But indifference curves don't intersect because of the transitivity principle. They have negative slopes. This is mainly because more is preferred to less. And so you can't be indifferent between a combination that has more of both goods. You would have to prefer that. to one that has less of both goods. So every combination to which you are indifferent has to have more of some good and less of the other. And so you get a downward to the right slope of the indifference curve. Obviously, if you're drawing indifference curves on a diagram, indifference curves further away from the origin, difference curves that had more of both goods would be preferred to those that have less of both goods. And this fourth assumption about the trade-off of y for x gives us the convexity of the indifference curve, which is important for the derivation of demand. Okay, so these would be the properties of the indifference curves. And then the derivation part, so here we have our utility theory, right? Like the analog to just preference rankings that we would have in the Austrian view. And then from here we have to go to the derivation of the law of demand. And let me work out a numeric example of this. Let's say that we had one utility combination, let's call it U1. In other words, the person is indifferent between all the different combinations of x and y. All these combinations that I'll list under here would give him the same utility. We'll call this utility sub 1. And the combinations then of x and y would be these. One combination would be 10 and 125. These are just in units of the goods. And then let's say 25 and 50. And then 50 and 25. And say 125 and 10. So that would be one, we could, if we put this on the graph, that would be one indifference curve. And then let's say we have another U2, which has more of both goods, and so it gives a higher utility. But again, for each of the combinations within this structure, the person is indifferent. He gets the same utility. So here are the combinations on that, for that utility level. Okay, and then the derivation, how we get the demand from this utility representation, is that the person is said to maximize utility, to get the highest utility level that he can, given his budget constraint. Again, you students of economics are familiar with this. So let's say that we have, for this person, an income of $100, and we have a price of X at $2 and a price for Y at $1. So this gives us the budget conditions, right? The budget constraint for this person. Now we can see that if this person only has $100 with these prices, he can't buy any combination on U2. Right? He can't reach this level of utility. He doesn't have enough money. And in fact, there are many combinations on U1 he can't buy. He can't buy this first combination, right? It's too expensive. He'd have to spend $125 just to get that amount of Y. So he can't purchase that combination. Now, he also can't purchase this combination, right? To get 50 units of Y, he'd have to spend his whole $100 at a price of $2 a unit. But he can buy this combination. Right?
The other way around.
Oh, did I mix it up? Oh, I'm sorry, right. Yeah, hey, good job. So it's the other way around, right? Okay, so he can buy this combination where... No, it's not the other way. Oh, yeah, I got the X wrong. Okay, so you can buy this combination 25-50, right? And no other combination. Every other combination is too expensive for him. And you remember what this looks like on a diagram. So we have this budget constraint, and we have this indifference curve, and it looks like 50-25, right? Okay, so he's maximizing utility given his budget constraint. And then we just map out to map out demand. We just change the let's say the price of X. So let's change the price of X. We have a new budget constraint with 100, and now the price of X is, let's lower it to 1, and the price of Y 1. Well, now he can buy on this higher utility level 50-50. Right? You can buy 50 of each. And so on the graph it looks like this. Right? The budget constraint shifts over, and he's now out here at 50. So we have the law of demand. And we have a quantitatively definite claim, right? The price was cut in half, and the quantity demanded increased 100-fold. I mean 100%. So we have something here we could test. We could go out and see, did this happen, and so on. Now, one last point about this derivation. Again, the whole point of going through this analysis, as I suggested before, is to try to preserve this ordinal structure of preference while having this kind of a derivation that gives us quantitatively definite results. It should be pointed out, though, that the whole exercise often in the literature ignores this tension between ordinal and cardinal, right? In other words, most of the time, if you see this approach done in the literature, they dispense with the diagrammatic approach, or doing charts and so on, and they go right to the formal mathematical presentation. In other words, they say, what we have here is a problem of maximizing utility. The utility function is x times y. The budget constraint is like that. And we just set up the Lagrangian, we do the partial differentiation, and we come up with the answer. We go direct. In other words, they're saying that this indifference curve analysis is in fact equivalent to the straight mathematical presentation. Cardinal units, constants in the functions, and the whole kit, right? Now, what criticisms then would we make of all of this? The first criticism would be that this really misconceives the whole project of microeconomics. Remember, we said in the Austrian view that a preference rank, let's say a hypothetical kind of preference rank that would exist would look something like this. We used the Honda Civic before, but it's sums of money against units of the good. In other words, what the person is really acting with respect to, what he's choosing between, is the price of the good, the sum of money, and units of the good. He has to be able to compare in his mind then these two things. This is what he's setting his valuation toward, right? It's comparing money, the value of money, to the value of the goods. And remember, the importance of conceiving of it this way is that if this were impossible, or if this isn't the way that it's done, then we lose the ability to explain how different valuations that people make in the division of labor are reconciled. The only way in which we can give an explanation of this reconciliation, how we engage in economic calculation and appraisement in the division of labor, is to show how ordinal preferences give us these cardinal numbers, prices and revenues and costs and so on, that can be used for appraisement. If we can't show the structure of that logic, then we haven't really accomplished the basic task of price theory. Right? That's the fundamental thing. Now, what's done, though, in this case? Well, in this case, what we have is, let's call this a utility rank. We can have this kind of utility rank, right, where we say, oh, we've got different combinations of the goods, let's say 2x and 1y, and then then we're ranking against this preferring or not preferring other combinations like this. And so obviously this is more of one good always being preferred to less of it. And then there are other cases where we would position the rank order the same. I'd say maybe this, deciding between these two bundles. You notice money doesn't enter into this at all, right? This is a direct comparison of a preference in your mind between one combination of goods and another combination of goods. What happened to money? How do we then proceed to demonstrate what we're striving to demonstrate in price theory? If all we have to begin with is a person is able in his mind to compare this combination of goods with another combination of goods. To put this somewhat differently, what this presupposes is what Mises called the neutrality of money. It presupposes, in other words, that people don't value money, that the value of money is somehow taken out of the equation of the valuing process. But it's only through valuing money that the solution to economizing in the division of labor emerges. And so this is just, again, it's fundamentally misdirected, we might say. Now, other criticisms that we might make of this approach, as we pointed out in the set of assumptions, indifference curve analysis requires a complete ranking of all possible combinations. A person must be able in his mind to rank all possible combinations, saying he's indifferent between these and not indifferent between, or prefers these to those. But clearly this is impossible for a human person to do. This is impossible. And so at this point, the mainstream takes a fallback position saying, well, utility theory then is really just about hypothetical agents, sort of rational agents. We don't presume anymore that we're talking about real flesh and blood human beings, but just agents of acting. And again, this seems to be problematic. Right? Is this really a representation of what real people do? Furthermore, we could point out that indifference itself is, as we suggested, not a praxeological notion. Praxeology is about action. Indifference doesn't lead to choice, and therefore doesn't have anything to do with action. It's a psychological principle. In other words, we could freely admit that people are indifferent between options sometimes, but this just means they don't choose. That's the meaning of the word, right? They can't choose between them on the basis of their value. Well, okay, so it isn't possible then for them to act with respect to indifference. The reason a person chooses some combination here is not because he's choosing between the combinations available to him on the utility, on the same level of utility. He's minimizing his monetary expenditure, right? That's why he does it. But again, this doesn't take account of the basic principle of action, which is preference. Also, this claim about the marginal rate of substitution diminishing as we move, the convexity of the indifference curve, as we move along the indifference curve. They call this the slope of the indifference curve, the marginal rate of substitution, the amount of y that's given up for each added x. This too doesn't seem to be consistent with what we know about utility theory. It wouldn't be consistent with the Austrian position on utility theory, right? In other words, it's not grounded in diminishing marginal utility. Diminishing marginal utility, remember, says that if a person has a unit of a good, he applies it to the highest valued end and then imputes value to it accordingly. And so if he has another unit, he satisfies a lesser valued end and imputes less value to it. His utility obviously isn't staying the same when he's doing this. His utility is increasing, right? More of a good is preferred to less. But the construction of the marginal rate of substitution is that in order to keep his utility the same, the person has to give up less and less y for each added unit of x. This is just, again, an entirely hypothetical kind of construct. How do we know what a person would do to keep his utility the same and giving up one thing for another? This certainly isn't just an application of diminishing marginal utility. Now, as we suggested before, this whole exercise is really, in a way, just a fig leaf, right? Most mainstream economists just, after you go through principles classes, just give up this whole facade of indifference curves and go directly to mathematical presentations, right? Directly to the derivation with Lagrangians and so on. And even sometimes in basic treatments, you see this, that the marginal rate of substitution is equal to the ratio of the marginal utilities. Right? And that so at the optimal point, at the point where you're maximizing utility, you're really establishing this condition: the marginal utility per dollar spent on each good is the same. This is the optimizing condition. Right, well, there again, you're presupposing cardinal utility. You're saying that there's some number for marginal utility, right? And so you're giving away the game and trying to preserve, square the circle, preserving ordinal rankings and yet having this mathematical representation. And just a couple more. I've taken too much time with this, but just let me mention a few other things. Indifference itself doesn't imply continuity of the function. Right? just says that people are indifferent. But these functions are almost always continuous, right? Or again, they just go directly to functional forms that they presume are continuous. Continuity is an added assumption, right? It's an added assumption that gives us an even more rigorous mathematical formulation of what utility would mean. In other words, it presupposes infinitesimal units of utility, that we can do calculus and so on. And then finally, indifference curve analysis doesn't really get us to the project that the mainstream is attempting to undertake here. Remember, the project is they want to start with ordinal ranks and then somehow give us, through this deduction process, give us the result of empirically testable propositions. But in order to have an empirically testable proposition, the indifference map would have to stay constant over time in order to have empirical evidence that could be used to test this particular quantitatively definite relationship, right? In other words, if from one purchase to the next the person's entire indifference map changed, then we would not have any empirical evidence that we could directly bring to bear upon some quantitatively definite proposition. We would have to throw up our hands, and say that, well, we're not really sure what's going on. Next week at the higher price, maybe this person, actually bought more of the good because his preferences changed in the interim. So the real critical assumption is not really addressed with the notion of indifference. The really critical assumption to get operationally meaningful laws is constancy of the underlying utility. And this again is not this is neither here nor there with respect to the idea of indifference. Well, I didn't get the costs, but we'll need to stop there in the interest of time. So, thank you all.